Get your day started right. From our shack to yours, this is Coffee and Ham Radios. We are live in 5, 4, 3, 2, 1.
Ladies and gentlemen, we are live.
Good morning, everybody. Hopefully that started off. Did we do that right? It looks like we're live.
I did my part.
You sit there and wait. That's the hard part. Hey, Rod, how you doing, buddy? We'll start off. I think we got a lot of stuff that we wanted to show / share today. If we don't get to it all, that's okay. So a lot of times we do videos that are 10 minutes, 15 minutes long, and we take a little bit of a deep dive across different types of tools or gadgets that we use in our ham shack. Really just to play around. I don't know if we're doing any science with them, but in any event, we get a lot of questions where people say, oh, how did you do that? I didn't know that you could do that. Or why would I do that? So what we decided to do is create this show. And if it goes well, we'll probably do a series of them where we just take different gadgets out of our ham shack. What's up, Joe Brett? How you doing, buddy? We'll take tools out of our ham shack and just put together a collection of short little clips of us doing stuff. That way we can ask questions, we can talk about it. And it just helps people learn. Like one time I did a video where I tested a coaxial cable for a short with a multimeter. And I got tons and tons of feedback around, hey, I didn't know that you could do that. That's super handy. Thanks for showing that. So that's the kind of point of today's show. I don't know if you believe in that or anything.
Yeah, I do. So consider this an Elmering session. Some of this stuff might be a little basic if you're an advanced ham, but we're also trying to bring new hams into the fold and bring them up to speed. And so that's where something like this is important to do. And Ape mentioned feedback on this if you find this valuable. And the only way that we can tell is through comments on the video and through that like button and through shares, which would get it more views. Our typical live stream replay it's not phenomenal. It's not bad. I'm not whining, but it's not phenomenal. And if this one here had a replay that was 1.25 better than normal or 1.2, 1.5 better than normal, that would be an indication that we're on the right track here. So if you guys want to share this out after you see it and let us know that, and we'll keep making more like this. And if it gets less performance, if it's like 0.75, then we'll never do it again. Strong signals either way are greatly appreciated.
Yeah, it looks like our buddy Steve. Hey, Swede, I can't click on the buttons because they're going too fast.
They move, yeah.
He just got a tiny SA. If you have any questions about that, feel free to DM me or hit me up. I play around with those quite a bit, and there's a lot of cool stuff that I figured out that the tiny SA is not heavily documented, especially from a ham's perspective. So, hey, look, we got Plasma in here. So welcome everybody. Thanks for joining. Unless anybody has I do have a quick thing I wanted to show and tell before we get started. I need to change my screen though. So see if I can figure out how to do this. I want to go to my desktop view, and there's my desktop view, but that's not, there we go. Eye in the sky view is the one I wanted to do.
That you can label those, you know that, right?
I got them labeled, but the labels are confusing to me.
High in the sky.
This is, am I on the big screen? Did I get big screen?
I can do that. I'll get you.
Thanks. My buddy Hayden, KB3GRG, sent me this. And it's a 3D printed Nano VNA case. And
nice.
He sent me a message and he's like, hey, what do you think of this? I'm like, it's awesome, man. And he's like, I'll send you one. I was like, please. It fits the Nano VNA H, the original model. And I can't find mine, but it's the same size as the Tiny SA. So I dropped the Tiny SA in here. But like you got your place up here for your cables and your parts and stuff, cables or connectors and parts, and then your reference standards up here. I just thought this thing was killer. So I said I'd give him a shout. He said he might make them for other folks. You'd have to cover some costs there, but I don't know if you think they're cool, drop one in chat, or you could probably DM them on the Toads Discord.
That made out of? Is that PLA? That looks.
This is like a marble filament. I think it's PLA, but I'm not 100% sure.
It looks very snazzy.
It is very snazzy. It's cool. I'm really stoked about it. So thanks again, Hayden. I totally appreciate it.
I need one for my Nano VNA, for my Tiny SA.
Right.
cases for all the
right, a
things.
needle went all the way across.
Right.
And then Colin is in the chat, MM0 OPX, and he just dropped a video. He's been doing a lot of really cool work around insertion loss when you use a 49-1 or a unon, right? That you would use for an NFED. And he dropped a video last night, and I think there's more to come there, but we're going to have him on again to talk about all the work that he did, because it's pretty good.
So that Nano VNA case, which call sign was that?
It is KB3GRG.
It's this Hayden. Okay, that's what I thought. I just wanted to make sure before I gave the wrong credit to the. I gave the right credit to the wrong person, the wrong credit to the right person. wanted to make sure. So if you want to reach out to Hayden, he's on Toad's Discord, and he would be easy to chat to about that Nano VNA case. I think that's a good looking case.
Yes, like he is saying PLA is how he does it.
PLA.
Awesome.
Okay.
I guess I could have just waited for him to say that.
And then we got Colin saying he needs it for his bits and bobs. I suppose you could put them in there too, but I use Nano. use that Nano VNA stuff for mine. But.
That means something
I
different.
mean, I'd be afraid of
there.
a pinch or something like that. That would be awkward.
All right. So with that, I think we're going to go ahead and get started, because we do have a bunch of stuff. If everybody's okay with that, did anybody
do it?
Did either you okay?
Roll
right,
that
folks.
beautiful bean footage.
All right, here we go. T, I'm gonna let you intro this if you don't. I don't know what you need to do, but
Okay, folks, we're going to do some multimeter basics. This is a Bio-NO battery. You can tell it by its ratings right here what you would be wanting to look for. It's a 12-volt, 3-amp-hour battery, and we're going to check to see what the battery voltage is. This has two different connectors on it, the typical Anderson power poles that we all know and love, and then it has a DC power jack. And if you don't have a DC power jack with any kind of specifications on it, it's probably going to be 2.5 by 5.5, and that's what this is. You really want to be careful with
Millimeters.
something like this, because there is a metal ring around the outside and there is a center pin on the inside. So we're not going to test that one here. What I would do if I was testing that is I would grab an adapter and adapt that to something with some safer test leads. If I wanted to shove my probe inside of that socket, I could short out the center pin to the outside, and that would be bad, and I don't want to do that. Okay, so this is a DC power pack. We know that because we know what we're looking at here. If you didn't know what you're looking at, let's just assume, and we'll just go straight into AC voltage, and we'll see what it says it is on AC voltage. I'm going to do black to black, and it just kind of goes weird. So
In a cycle
probably not
weird.
AC. Let's assume now that it's DC. I'm going to go black to black and red to red, and we get a nice solid reading of 13.323 volts. And some of that movement is me just moving my hands around, causes it to move around a bit. But black to black, red to red, positive to positive, negative to negative gives you 13.23 volts. A 12-volt battery is going to be more than 12 volts by its nature until it starts to tail off when it has no juice left in it. So that's why we're going to read a little bit above 12 volts on that. I'm going to do this backwards to illustrate what happens when you read it backwards. So
You stole my thunder.
backwards, it's going to be negative 13.32 something volts. And that's a good indication that you've got it backwards. So all you got to do is pull them out, switch them around, put them back in the right way, and you'll get positive readings. If I touch the
Positive
probe.
vibes, everybody.
There we go. 13.32 something volts. Perfect. So some applications you are
Perfect.
going to have negative battery voltage, but since it says 12 volts, I'm looking for positive battery voltage, and that's how I can tell that I've got a good battery and a good reading. I'm looking for positive. I see positive. Everything is positive.
That was a very positive, self-affirming video, too.
Namaste.
Hippie.
well, see, the thing is, a lot of times we'll take things like that for you would just say that, oh, people already know how to do this, but everybody's got to learn something at some point in time. So it's like super duper handy. And then as we do more of these videos, you'll be inside like a radio or maybe some kind of gadget or something like that. You might need to test if voltage is getting to a certain stage in your device, and you can use a multimeter to do the same thing. So that's awesome. I appreciate it.
And there are places where voltage will be negative in a circuit. That's not necessarily a bad thing that it's negative. It's just it is what it is.
Just stop and ask yourself, am I doing the thing I set out to do?
Right. Oh Lord.
I don't know if we were ready for that or not. I was just
No one is ready for that. I'm just saying.
And I clicked another one. But yeah, Hollywood. The thing is that we just wanted to start basic, and in each one of these shows, I think we'll show basic stuff and then get to more advanced stuff as we go. Hey, Andy, how you doing, bud? All right, well then I guess we'll kick off the next one. This is James, our friend James here. I don't know if you had anything that you needed to say or anything, but here it goes.
No, there might be some
we want to
overlap
measure
with
the
Steve's.
voltage of our battery. And there's multiple tools we can use to measure battery voltage. A multimeter, we can also use this multifunction oscilloscope. So we're going to do this real quick on the meter. We're going to set our range. Some meters are auto ranging. Some have a specific voltage range. So on this guy, it is not auto ranging. We're going to set it to the 20 volt scale. And we're going to make sure that he's on DC voltage, and he is, because he does not say AC. And we're going to test our battery. And you can see that we're showing minus 9.39 volts. That's because I don't have the probes on the right polarity.
Battery's sucking power out of the atmosphere.
That's right.
Free energy.
And there we go. Now it's 9.4 volts. So now that is us measuring the battery voltage. Now this is not under load. That's a different show. So we'll turn that off and we'll scoot him out of the way.
And that's probably something we need to
And
do.
let's
in the
turn on
future,
our
too.
meter.
It is.
I mean our oscilloscope. Now with the oscilloscope, there's 2 or 3 ways we can do this. The first way is just like I did with the meter. So I can hit mode on this particular device, and I can set this guy, and he's already set for volts. I have a millivolt scale and a volt scale. He's on DC. This actually changes my function, ohms, continuity, diode, and capacitance tests. We're going to do DC voltage. And we do it the exact same way we did it before. I put the probes on the battery connectors,
It puts the lotion
and
on
we
its
have a
skin.
reading. And once again, I got the probes
Yes, it
backwards
gets
from the
those again.
correct polarity. Doesn't matter for what we're trying to do. So 9
You can see
volts.
that O1 screen so much better
Great.
than the meter.
That
It
works
is nice.
awesome. How else can we do it? Well, with this particular device, this is a meter. I can use a different set of cables, but those aren't going to fit there, are they? Nope. So we switch over our mode to our oscilloscope mode. We can DC these cables. That means disconnect. And we can use
I
either the
say
alligator
things sometimes
put
that's
BNC
what we always
setup,
called it in the fire department.
or we can use
and I
the
just say it
probe.
and I'm like, I'm going to
Either
edit
one
that
will
out.
work. Since I have the probe already unpackaged and calibrated, and you should have seen how to calibrate a probe on Ape's channel the other day, and I've had it on my channel
Dang right.
before.
I mean, I
about
had to
calibrating
show you how to do it,
oscilloscope
but it's
probes.
okay. It's all right. Just saying.
And I need to check voltage. So we're going to hook up our leads and hope that that stays connected.
And then I didn't
And
have
we
this
are
set
going
up,
to
so
set
there
our
should
measuring on.
Here we go.
Now this may or may not be the fastest way to check voltage, but we certainly
It
can
ain't. It
check
ain't
voltage
the
this way.
fastest. And then I was
It's
like,
one of the
go ahead.
ahead.
No,
I
go
was going
ahead.
to say, one of the cool things you can do with something like this is just have one tool on your desk. So if you just had room
Okay,
on
so
your
I
desk for
have
a
the scope set
you
up.
could
Now
do
I
scope and
could
meter
have
stuff.
cheated and hit the auto button,
Right.
which would have made this a little faster. So our 0 line is the center line here, and we're set to 5 volts per division, and we have most of 2 lines on our 9.4 volt output battery. So there's our voltage. And you can see our voltage down here shows, it's kind of hard to see on the camera, 9.398 is what we're getting here. So you can do it this way. You can use it as a meter. You can measure it on the oscilloscope. There you go. Measuring voltage.
So the Swede's asking if that's a Swiss Army knife of
Heck.
multimeters.
Yes.
Yeah, and so what you don't see on there is a sine wave, and it's because that is a DC current, not an AC current.
Right.
Right.
It don't wave.
So folks may be confused about that, but one of the reasons why we like to show that is it's kind of dumb to measure a battery with that when you have other ways to do it. But there'll be times where you need to measure inside a circuit, and it's the same technique. It's just it's not a battery, it's the circuit. So it's a building block for moving forward.
How much is that little scope?
Well, it depends on which model. That model is about $225.
It's about the same price as a regular scope now. Is a regular scope like $3?
You can get a form factor, the scope form factor instead of the meter form factor for probably mid to upper twos. That's 100 megahertz 2-channel. That's 100 megahertz 2-channel with a built-in signal generator, which you're not normally going to get in a scope like that. So that's a little bit of a plus. It's a little pricey, maybe. You're getting into which way is better to go, but like it is a Swiss Army knife because you said it. That's like one thing on the bench right there in front of you: capacitors, diodes, voltage, continuity. I got an oscilloscope, and I can throw a signal into my circuit if I want to do it that way. So
yeah, that jack of all trades thing, it makes it really sexy.
Yeah, would I use an oscilloscope to measure voltage on a 9-volt battery? No.
What I've seen a lot of people say is that if you have a signal generator, a multimeter, and a scope on your desk, it takes up a significant amount of space.
It does.
I think that device is really targeted towards makers who need to inject sound into like an Arduino project or something like that, and then use a scope at the same time to look at the signal quality on the output side. And it's perfect. It's perfect for that. And what's neat about it is that your multimeter, your signal generator, and your oscilloscope are all on when you turn that on. So when you switch modes, it doesn't turn one off. Mm-hmm. So as a result, that has two 18650 lithium-ion batteries inside of it. It does take some juice to run that device.
And so two things I want to add in there, which I didn't mention, and we probably said it before, but since that's a battery-operated scope, that's got a floating ground. So you can mess with AC higher voltage circuits without worrying about crossing the streams. Now, there's still a maximum voltage rating on that scope, and I don't remember what it is. I think it might be...
I think it's 400, but check the manual before you take my word.
Yeah, I think it's 400, but so you could probe around on mains voltage without worrying about putting the ground on a hot wire and vice versa. The other thing that I wanted to show you, which I meant to put in the video, but I did not, is these things are nice. if you're checking batteries, these things are great, and I've got several of them. My wife has one of them that has just a little meter to tell you whether the battery is good or not. And this will tell you under load because this technically puts a load on it. You can also just put a resistor in series when you do the check too. But.
Yeah, I keep a little multimeter on my desk at work for checking batteries because it's something we have to do all the time.
Right.
Oh no. This is the alarm that goes off when we have more people watching than likes. So if you would help us out there, and we don't have to worry about the alarm going off.
Really?
There we go. Right.
Automation.
And John's asking if they work for 18650, and they do. You can test an 18650 with that.
Yes. This if he's talking about this gadget, yeah,
the battery tester.
If it fits, it ships. So
the battery tester. I thought he was talking about the O1.
The scope for sure, yeah. So while we were showing Jim's video, you guys had said, and I was kind of like, just in
these aren't even 18650s. These are bigger. I don't know what size that is, but that is bigger than a 650, and yeah, it absolutely works. So
I think it's a 27200 is what that is.
So Hollywood's adding another note, but I was asking you while Jim's video was playing, you guys said, we're going to have to make a note of that. And I'm like, what are we making a note of? Because I didn't write it down.
It's testing the battery under load.
Testing the battery under load.
Okay. So Hollywood just stole your idea. Okay. Making sure.
I got it on the list.
That's how they get you.
There we go. Don't mix high voltage AC grounds with low voltage DC grounds. You get blue flames and black smoke. Don't ask how he knows.
Oh,
mistakes were made. Mistakes were made.
Grounds and Scopes is a whole 3-hour show that we'll do in the future.
Grounds and scopes is probably something where, I don't know, I'm like, you should read the manual and fully understand the operation of your equipment and consult a professional electrician and an engineer before you start doing this. Don't take no YouTuber's advice on how to hook up an oscilloscope to mains power. Just saying.
It should test a 20 amp hour battery. We're testing for voltage, not amps in that particular test. Although later in the show, we test for amperage. And I got to tell you, 2 of the times that were the scariest for me in terms of letting smoke out and sparks going everywhere, I was testing amperage. So you just have to be careful there. And then Alon, he's saying that protected 18650 is the same diameter, but a few millimeters longer. If I go back to my vaping days, that looks like a 27100, which is a little bit rounder and a little bit taller as well.
Yeah, this guy, I don't know. Continue on, and I will do the research.
And then the Swede wants to know if any ham fully understands their equipment. And the answer is no, because a true ham does not read the instruction manual.
Right?
So.
Manual, what?
What's that?
Yeah, we were talking about with grounding.
That book is to swat bugs with, not for you to read.
Yeah, Matt's
Raise
making
your screen height up.
A great point there. So, like, what's funny is that people who get into seriously testing stuff, they'll talk about these AC isolation transformers, and a good one's about $200. And they're like, "Yeah, I just don't want to spend $200." But it's like, do you want people in the room to be able to see your skeleton for a few seconds? You know, when you get lit up, it's a good idea to do that.
Well, it says 18650, but it sure looked bigger to me. I don't know.
So this is a quick Nano VNA video, which we all love the Nano VNAs. So here we go.
This guy.
Okay, so what we're going to do in this video is that we are going to test the response of this filter. It's a low-pass filter that's designed in what is called a Pi network. So if you take a look at this, you have obviously your 2 inline connectors. These are SMA. And we're using a Nano VNA test board, which is a device that allows us to prototype and rebuild circuits and then test them easily with a tool like a Nano VNA. Anyhow, what we have is we have an inductor, and then we have 2 capacitors here, and they are kind of in the shape of the character for Pi, and that's why this is called a Pi filter. This is designed as a low-pass filter, which cuts off frequencies at a certain frequency and only allows the frequencies below that to pass. Frequencies that are higher are attenuated. And when we design things, we like to prototype them and then test them out to see how they'll perform in real world conditions. So what we're going to do now is we're going to connect this up to our Nano VNA, and I'll show you how we can test the response of this filter. Okay, so this is a relatively simple setup, but there's a couple of things we need to pay attention to. This is our Nano VNA, and this is a Nano VNA H. It happens to be one of the ones that I like the best. So we have channel 1 and channel 0, and channel 0 is the origin point for our signal. So what we're going to do is we're going to shoot a signal out channel 0 up through this wire into our test board. Now our test board does have an in and an out port, but because this is a circuit that's the same way each direction, it really doesn't matter that much. But I do want to make sure I plug this into the in port, which you can see there. And then coming out of the out port, then we're going to go into channel 0. And we're going to do what is called an S21 measurement. And that is to measure signal out. We're going to measure it here, where it comes in, and we're going to be able to see the response. So here's my Nano VNA. Let me get a closer look at this so we can kind of understand what's going to happen next. Okay, so here's my Nano VNA, and there's a couple things that we want to do here. First, I want to go into the menu, and I want to go into the display, and then I want to make sure that I have the appropriate trace on. So I'm going to go into the trace menu. I'm going to turn on trace 1, and that is going to be my S21 trace. And then I'm also going to turn off trace 0 because it'll just cloud my screen and cause confusion. So now I'm going to go ahead and I'm going to hit back, and I'm going to hit back again. And what I can see here is the trace or the return path, but I really can't see everything. So one of the things that I want to mention is that you can see down here, my start frequency is 6.5 megahertz. And I know that this filter right here, you can see marker 1, it is at 17.6 megahertz. And then my span only goes up to 30 megahertz. So what I'm going to do is I'm going to expand my range here. So let me go in here. And then I'm going to go into stimulus, and then I'm going to change my start. Oops. I'm going to change my start to, I don't know, let's just say 2 megahertz. And then you can see up here where there is no attenuation on our frequency span from the filter. And then, so I can make this look a little bit more dramatic. I'm going to go ahead and I'm going to take my my stop frequency, and then I'm going to extend that to 50 megahertz. There you go. And then you can see more steeply the roll-off angle there of this particular filter, and then you can decide if that filter is good for you or not. Something to point out, my Nano VNA was calibrated for the original setting, so you can see here that this C0 is telling me that I am using a measurement or a span that is not it's not synchronized with my calibration. Is it a big deal or not? For this demonstration, I'm going to go ahead and say no. Anyhow, thanks for watching. So the thing about that is that you can do through measurements with a Nano VNA. You can't do that with a Rig Expert, and that's why the Nano VNA is a superior device, Don.
Jeez. Man.
He makes a really good point here where he says he knows this because Shane did it. Don't sweep a multi-band antenna with a bandpass filter in place. It doesn't blow up, but it's not what you're looking for. And correct. What's important about that is a lot of times people use test equipment, come up with a test case scenario, and they'll test it.
Wrong answer.
And they get the wrong answer. And they are extremely confident, where they're like, the meter don't lie, boy. I tested twice. And the thing is that you need to evaluate your test conditions and making sure.
Sanity check.
Steve saying don't do only if you're testing sweeping a hand stick.
Y'all are trying to trigger each other this morning, aren't you? Steve's throwing out the
the
ham pam.
So in a later test, what we're going to do. So I did a video on this earlier this week, and this is it's a T-Network tuner from MFJ. It's an antenna tuner. And it has an input and an output. So what we can do is that exact same measurement. That's a really handy measurement here, where we can say one side of the Nano VNA goes in on the transmitter side, and the other side comes out on the antenna side. And then we can actually measure the insertion loss of this device. So, you get a lot of folks who are like, I don't use no damn tuner because it causes losses. And that's what they're talking about. Some people expertly know that without ever testing it. And I guarantee there will be losses when we run through this, but I don't know exactly what they're going to be.
And Jim W6LG did a great video one time on insertion loss. He hooked up an adapter with about 50 or 60 coax adapters from like SMA to N to PL to, and it was this huge. The camera's not big enough. This huge adapter chain, and the insertion loss was incredibly minor. So, but he actually tested it too. He didn't just say it doesn't make any difference. He tested it.
So it looks like Don said they were sweeping a car Artemis. Fantastic antenna, by the way. And it was strange that it was only resonant on 40. If you have a 40 meter bandpass filter on your antenna, and then you only see it active on 40, that's why.
Right. And Hollywood is making a point. I call that a sanity check. But yeah, if the values you get are not making any sense, then you need to reassess what you're testing and how you're testing.
Yeah. So this is actually really good to point out. So what happened was in my battery video that we led off with, I made a whole bunch of assumptions. Yeah. I made a whole bunch of assumptions and then kind of explained those assumptions backwards. And Greg says this better than I said it. I picked up a battery that I knew was DC. I knew it was in the 12 volt range, and I knew I wanted to get a positive result out of it. And I touched on it, but I didn't say it as good as Greg does. Pick it up, look at it, determine what you want to get. I want to know if this is greater than 12 volts or less than 12 volts. If it's less than 12 volts, I need to charge it. If I plug everything in correctly and it's reading negative, then there's something wrong with the battery or there's something wrong with my test condition, and then figure that out. So battery voltage positive, battery voltage greater than 12 volts, this battery's good is the answer that I was going for. And again, we're at this level, and there's nothing wrong with being at this level, and there's nothing wrong with being at this level, but we're trying to fill that gap, and it's hard.
I was just hoping you to not see that ape. Don, go get some coffee and have a sweet roll or something.
Fiber. He's a fiber over there.
He might.
So what Don is saying is,
y'all keep tweaking the ape. He's going to need some fiber too, and Ed Miller.
what Don is saying is that he will give you $150 towards the purchase of a Rig Expert, so that way your $50 contribution will get you the $200 cost of the Rig Expert.
Oh,
that's very nice of you, Don.
Travis is saying anything after the output of your transmitter has a loss, and that is absolutely true.
Right.
Especially your coax cable. So a lot of hams, and I don't do this, and I feel terrible because I don't. Is they use ladder line or twin line or window line or whatever you want to call it, because it is less lossless than coaxial cable, and that has some really big impacts on how SWR is handled. But he's totally right. Anything that you have in that chain is going to cause loss. And again, that's why nano VNAs are so fantastic, because they allow you to measure the loss of each of those devices, and then you can get a cumulative loss total. Something you can't do with a Rig Expert.
Because it's only a single port. You can do it with the spectrum analyzer.
And I'm not hating on Rig Experts. I like them. But the nano VNA is super duper sweet.
And it's easier to use.
Let's see what we got next on that.
Not.
James did a filter video. I didn't know that.
You told me to.
Well, I asked.
All right, guys, what we're going to do is we're going to look at our filter using a spectrum analyzer. This is similar to what Ape showed us. We're doing the same procedure. We're using a different piece of test gear. This is a Regal DSA 815 spectrum analyzer. And what we have is the tracking generator, which is our signal creation device, going to the input of our 125 kilohertz bandpass filter. And that comes out of the filter to the input of the spectrum analyzer. I've set my center frequency for 125 kilohertz. The spectrum analyzer decided that I was going to start at 40 and end at 210 kilohertz, which is dead center 125. So
I hope
what we're going to do here is we're going to turn on the tracking generator. And if I have this set right, when I enable the tracking generator, there is our bandpass.
That is what a filter looks like.
And you can see that it is so 10, 20, 30, 40, 50 dB higher.
A good essay would just tell you
more signal is coming in.
It would, but that was like complicated, and I didn't want to set all that
up. Now we can
up.
Adjust this to characterize the filter and change our tracking generator level. And I can bring this up to 0, but all it's basically doing is moving the same thing up all the way to 0, or pretty close.
I think I had the RBW on that pretty tight too.
So you can see down here, we're at minus 70 dB below unity. So this is a solid bandpass filter, and it definitely wants to let the 125 kilohertz band go through. Quickly, we can put markers on this, and we can see that our filter starts at about 118 megahertz.
To do this really good, you'd have to zoom that in, and that was just going to make it longer, so I didn't do that. I'm kind of eyeballing this.
136. So we'll call the bandwidth of this bandpass filter
the pass band
18 megahertz, with 125 being roughly the center of the filter. All right, that's it.
I apologize for that audio. I forgot to clean out the whooshy sounds.
Well, you know, shame on you. But
I was unprofessional.
What's cool about it is that in this picture, so you can measure this similar things with multiple devices and kind of come to the same answers. But like where the cursor is there, and where Jim's talking about the pass band width and how much frequency goes through the filter, that's called your roll off, and that's at the shoulder, the peak of that mesa, I guess is what you would call that. And typically, it's considered at 3 dB down is where you would consider the effective range of your filter. Now those arcs or slopes on either side, they're called skirts.
The skirt,
for whatever reason. So when Jim posted this, I'm like, nice skirt, bro.
Easy.
You can see the one on the left is a little steeper than the one on the right, but now it looks like a good filter.
And what you could do, like I said, if I had spent more, this is just supposed to be a short video, but I could have zoomed this in and gotten us a much tighter view. Like when Ape did it on the Nano VNA, he was not showing the whole, around it. He was showing just the in-depth part. And we could have seen exactly where that 3 dB roll-off was on either side. But
can't show everything all the time.
For our purposes, it is what it is.
Well, that's why we're looking at it from multiple angles. So like when I did it, what I wanted to stress was the ability or capability of an S21 measurement, and why that's important. Because, like I said, we're going to do multiple S21 measurements over the next series, and wow everybody with trickery. So Don wants to see one with short skirts. Oh, I clicked the wrong one, or somebody else clicked it wrong. There we go.
No,
groovy, baby.
Don't be blame shifting. Own it.
Well, we all three have the power, so it's like there's a lot of random.
We're doing pretty good collaborating with it today, without stepping on each other too bad. But can you folks share the videos, or is it just me that can do that?
I think it's going to be you.
Let me see.
Did you share them as a slide or a video file?
No, you got to click and share, and then go down and pick. Oh, you know what? You can't because they're on my machine.
Yeah, I can't.
Yeah. You'd have to get them off of the.
You didn't upload them to StreamYard.
I mean, I could get on your machine if you want.
No.
I was the other day, but it doesn't matter.
So next one we got is Tio does a DC polarity video, and let's take a quick look at this one. Polarizing. The polarity video is very polarizing.
Right. Let me put on my peril sensitive
so here
glasses.
is another piece of the puzzle. We already did DC voltage, DC battery test last time. Now we've got a DC power cord. It has power poles on one side, and it has a DC power jack on the other side. And these are pretty obvious. Red should be positive, black should be negative all the time. That should be a standard.
Mostly.
You know how standards are. This one, on the other hand, it could be center positive or it could be center negative, depending on things. I don't know. Sometimes there's a diagram on the backside. Let's take a look at that. Where is it? Can we even see that?
Yeah.
Should be a diagram on the backside. It's not the easiest thing in the world to read. This is a plus sign.
Right.
It's got a line that goes to the center pin. Doesn't have a center pin. We'll just have to assume they're talking about the inside. It has a negative sign with a line that goes to an outer circle that goes around the outside of the center pin. So we should assume that this is center positive. So we've got red on one side, and we have who knows on the other side. So we'll need to test this out. I'm going to plug this into my power supply.
Look at that. Fuse on positive and negative. ICOM knows what's up.
Grounding is fake news.
Power on this jack. And it's supposed to be center positive, so we can test that out by putting a probe in the center, setting this up for DC. We already figured out how to tell whether we were DC or AC last time. And now we're at 13.69 volts, 13.7 volts, whatever. So now I know that in fact is center positive. I've got my positive probe inside the center, my negative probe on the outside. If I get these things reversed, I put my negative probe on the inside, and I put my positive probe on the outside, it will show negative on the meter. So you've got it backwards based on what we're trying to accomplish. I want to see if it's center positive in the center, negative on the outside, and it's giving me a positive reading. There you go. Now I know that this is safe based on looking in my owner's manual for my radio. So I can plug this into my radio, and my charging light comes on, and I can hit the power button. And we get 8.2 volts and 13.7 volts external. We are good to go.
Perfect.
Safety first, folks.
Well, that also checks and makes sure that you don't have any shorts in your wire, right? And that the integrity of the wire is good. So that is that's a pro move there, is checking your cables like that. I don't always do it, which is bad, but it's a good habit to be in, to do something like that. And as Stump mentions, there's a bunch of different ways that you can do all of these tests. Our job is just to show a couple of them, and hopefully we hit all of them over the course of time. But that's a good test. That's why I wanted to make sure. Tio actually did that in a previous video that we did, and I was like, oh, we got to make sure that we do that. We got to make sure we do that one. Let me see what else we got in the bucket here.
It was in last week's PrepCom video.
Right. It was. All right. Well, we're cruising right along. We're doing pretty good. We have James doing a continuity test, which is what Thump was just talking about.
Okay, now we want to measure continuity. And we can, again, use these two tools to do this. There are multiple methods for some of this. These are just the two methods I'm going to show you. We turn on our meter. This is the ProseKit MT5211. This meter is used by Electro Boom. If you don't follow him, you should. He's awesome to watch. So we want to test continuity. So
maybe
on
a
this
little
meter,
bit of a bromance there. Just saying.
It's that little symbol there.
Another one?
So we rotate over.
I'm polybromantic.
And we've set it to continuity. And then you'll see in the upper right hand corner we have the diode symbol. This also does diode testing as well, but it verifies the electrical connection and decides which way to do. So we want to test continuity. Continuity is to see if two wires are touching each other.
My favorite sound.
Clear!
I now have a little sound icon up there, continuity mode. So our shield on this connector on the SO239 side should be connected to the BNC side.
And I did not check the center pin, and I don't know why I didn't. I just completely had a brain fart on that.
So that is with a standard meter.
Truly.
This scope is in
Jim's favorite
multimeter mode again. This you cannot really do with the oscilloscope, but we want to change the function from resistance over to continuity, so we're going to press that button one time, and that scoots this guy over to the little speaker icon, which is continuity mode. And so we're going to once again test our shields, and he gives us a resistance reading as well,
which is kind of special, honestly.
All right, that's continuity tests on two different devices.
So one of the things is that when you take a look at that O1 meter versus the ProseKit meter, let me see if I can rewind this. And what you can see is that when Jim set this to test continuity, he didn't have to put it on any range, and you actually don't have to put it on any range with the ProseKit either. But when you look at the dial on that ProseKit, you have all of these different settings, and that can be intimidating at first. Like I remember the first time I was holding a multimeter.
Yeah.
I'm like, what in the hell does all this stuff mean? And I had no idea because there's symbols and numbers and ranges and all that.
I don't like ranges.
Yeah, some people love them because they say that it's faster. You know, but if I know the range, and it goes back to what Hollywood was saying, where is that if you have an estimation of what your value should be, perhaps a manual range device is the device for you. But if you find a resistor and you look at it and you can't see like me and you can't read the band, so you have no idea what it's going to be.
I don't even know where to start. That's right.
Right. You just set it to auto range, and not all meters do that. Some meters do both, but most do one or the other. So I know Jim loves that ProseKit. I'm not sold on it.
It's fine. I mean, and that Harbor Freight / whatever it is you figured out it is also works. That thing's 1,000 years old.
Yeah.
And still works for what I do. That ProseKit is fine.
I'm sure it is.
Electro Boom hasn't burnt his up yet, so there's a plus.
I just like to pick certain things like the ProseKit, the ham stick, and just
pick on them and
start constantly be negative about it.
What are you using? The Anang House of Fish Market and Meter Company Incorporated meter? Is that
you forgot Tire Center?
And Tire Center, that's right.
Yeah. My desktop meter is a fluke, son. I don't know.
Oh, look at him flexing! Oh my God,
that's the one that sits on his desk, intimidating him because he doesn't know how to use it right.
Well, I also got the EEV blog. So, I mean, I'm just saying. I'm just kidding. I think that having a meter is valuable, so I don't want to shun anybody away from having one, regardless of what it is.
Electro Boom is greater than EEV blog.
He's more entertaining. EEV blog is really, really bright person, but the voice. It grates on me.
I know. He's super smart, but that voice is like fingernails on glass.
Tio, you do a pretty good impersonation of that guy.
Hi.
Hi. Hi. And then when he gets excited, it gets higher and more piercing.
Yeah. And I watch everything at 2x, so imagine that.
Oh my God.
It goes a little faster. So if there's any, here we go.
That's right.
That is a sign of
natural
authority.
Separation.
That is a sign of authority.
I will say one thing on the continuity test, and I mentioned this, but so if I was really trying to continuity test that adapter to make sure it was correctly wired, you need to test. What I always do is I'll test the shields, I'll test the centers, and then I'll put the center to the shield and make sure that it's not got continuity.
You don't have a short in your wire.
Right, for a cable. So those 3 checks will clear a wire. And I didn't show you guys that. It's all the same. It still beeps or not beeps as appropriate.
Yeah, so Rod says his dad smoked a meter one time. I got to tell you, it was probably about 20 years ago when I had bought my first meter. I was playing around with it, and it was one of those manual ranging ones, and I had no idea what any of those settings was. And I was just testing random stuff, and I'm just like turning the meter until I get numbers on the screen thinking, oh, look at me.
Why it was connected?
Yep, and I smoked it. And the thing is that I didn't know enough about it, so I ended up throwing it away and getting in the car and driving back to Walmart and buying another one. It was like $11, but what I had done is I blew the fuse inside of it, so it was perfectly, more than perfectly serviceable. But I didn't even know that they had fuses inside of them. So maybe we'll do a multimeter dissection in one of these. All right. If there's nothing else, we'll just keep on trucking.
Keep on trucking.
Oh, here's the current test. Now, what I'm going to disclaimer this: don't do this unless you read the manuals and all that stuff.
Ape is a trained.
Okay, so when you do a test like this, the first thing that you need to use is your brain. I'm not telling you to test current or amperage like this, but this is how I'm going to test it. And I would encourage you to read the instruction manuals for everything that you have, understand electricity, and then make an informed decision based off of your equipment, experience, and skill set.
Oh my God.
That being said, what we have here is an EEV blog multimeter. And this is rated to be able to test up to 10 amps of current. Hi! So here we have our Retevis RT95 25 watt ham radio. And I know that at its max consumption, it's not going to exceed 10 amps. So doing a test like this is relatively not a big deal. So from my MFJ power supply, I have power coming into my meter in the input for testing amperage. You can see the A right here. And then coming out of the common, you typically have a black wire, but I still have a red wire because this red wire loops around and it feeds into these power pole connectors, which goes into the back of the Retevis radio. Now coming back out of the radio on the black ground is a black wire here, and then you can see the other end of it here, and that goes right back into my power supply on my negative. So when you're testing amps or you're testing current, what you need to do is you need to put your meter in line with the current draw in order to test it. And so that's what we've done here. Here you can see the Retevis radio is running, and it is reporting 13.6 volts, which is exactly what my MFJ meter power source says it is putting out. And then here you can see the at-rest current draw, so it's 0.017 amps. So what I want to do now is I want to key this up, and I have it set on high, and we're going into a dummy load. You might be able to see it back here, so we're not at danger or risk or anything like that. And I'm just going to go ahead and I'm going to key this up, and then you will be able to see the current draw through the meter. And hopefully you could see that. Test.
It wasn't much.
So what you can do is you can measure the current that your device is going to use or consume this way. Thanks for watching.
So that was 0.009 amps draw. Is that what that was reading?
When I hit the button, I didn't hold the button in, so I hit its peak, and I think the peak was somewhere around 9, but I'd have to go back and take a look at it.
I'm trying to move the slider here to see where you hit the button.
You know, the Pros Kit will hold the reading for you.
I'm sure this will too. It has a maximum.
See, here you're hitting the button. I'm playing the video. I'm just trying to make sense of the reading because the meter goes crazy when you read it, and then it settles back down.
That's got to be more like an amp or 2. What did you transmit that on? 5 watts or 10, or do you remember?
I have no idea. I don't remember. I was just doing the test.
Okay.
So we did get a question here from Don. Let me show it real quick.
Audio.
He says, can you show us an easy way to measure the effectiveness of a ground rod in the backyard, and better yet, the effectiveness of your location giving you a good ground?
I made a note.
So I don't know a good way to do that. But we do want to talk a little bit about it. Like you ground for a couple of different reasons. Like you want to bleed off static and from your antenna potentially. You ground for lightning protection. You do a safety ground to make sure that all of your equipment is the same voltage and you don't get bit there. So when you measure AC current in any form or fashion, you have to do it at a particular frequency. So your multimeter has a built-in frequency that attests it. And we should all know that as hams, because we know that when we measure like an antenna or coax or something like that, at different frequencies, we get different measurements because of something called reactance, right? So you have resistance and then you have impedance. So impedance is resistance plus reactance, which is either capacitive or inductive reactance. You have resonance when they cancel each other out and you have pure resistance. When you want to route electricity to ground, especially things like lightning strike has a very, very low frequency. It's like sub 60 hertz, and AC mains is 60 hertz. So what you need is you need a super duper low impedance path to ground for electricity at those frequencies to get out to your ground rod. I don't know a good clean way to measure that. We can look into it, but I don't know how you measure ground rod effectiveness. And there's other things like the number of ground rods and how close ground rods are together. For example, if you live in something like townhouses or row houses, your ground rods out back are going to be so close together that you can actually pass current to each one of those, depending upon the conductivity ability of the ground. So I'm sorry about that. I'm not a grounding expert enough to really answer
the type
that.
We will be by the next show, though.
The type tomorrow of soil. Morning. Yeah. There's no show tomorrow morning, Abe.
Oh.
Well, it's gonna vary on the type of soil too, not just the physical distance, but right. Clay is probably, if I had to guess, and I'm guessing, clay is probably less conductive than a wet loam type soil. I don't know. But I mean, there's going to be differences because the density of the material, the amount of water retained in the soil, the mineral content of the soil, the barometric pressure in months ending with re. I mean, there's a whole lot of factors there. I don't know how to measure it.
I think Don just volunteered to come on the next show.
Well, so he's trolling. He's still mad at you about the other.
Yeah, and then Matt's got a earth resistant measurement is a dedicated tool, $100 to $200 for an average quality meter. So.
Matt, do you have one?
Jim should buy one.
No. Shut up.
He's already got two in the cart.
No, Jim does not have two in the cart. Jim has another gadget he bought last weekend that's about to go back in the cart.
You have what's that now?
We won't talk about that.
All right.
We talked about it the other day. You know what
I'm okay. I think I know what you mean now.
Same thing. Mm-hmm.
All right. Well, let's I don't think we have anything any questions. No stones left unturned. Let's
no turns left unstoned.
Let's go back and see what we have next on the list. So T.O. is going to measure some SWR with a nano VNA.
Okay, this is a nano VNA. This is a very tiny handheld vector network analyzer. And that means it does a whole lot of stuff that is not terribly important what we're going to do right now. Right now, we're going to test the SWR of the super elastic signal stick antenna. This is made by Signal Stuff, and all of the profits from selling this antenna go towards hamstudy.org, and that allows you to study, and it goes towards exam tools, which allows you to take your test online. So that is a fantastic cause, and I support super elastic signal sticks and signal stalks and so on. They make a lot of products, including mobile antennas and so forth. So fantastic stuff right there. All I'm going to do is test the SWR with this, and because of the price of this device, it doesn't hurt that you don't even use all the rest of the functionality. This is around $50, and we recommend you get it from R&L Electronics. Very tiny device. They do make these in a 4-inch. This is about a 2.5-inch screen, I believe. They do make this in a 4-inch screen, which is even bigger and easier to read. These things over here are called test standards. I'm going to totally skip those. We've done plenty of calibrations in prior videos. That's not what this is about. And the reason why I can skip those is because those test standards did not change since the last time I calibrated this device. So what I'm going to do is I am going to recall my saved calibration from the last time I calibrated. because my recall 0 is my default no specialty calibration. In order to test the SWR of the antenna, you need to make sure that you have your SWR set and your Smith chart set. You can kind of skip the Smith chart, but it's pretty. I like it. So what I'm going to do is I'm going to go back to display. I'm going to hit trace, and trace 0 is highlighted and checked, and it's yellow in color. So now we want to check the format on trace 0, and SWR is checked. So we know it's the SWR. It actually says it right there, but that would be how you would change it to something else. Same thing for display, trace. We're going to pick number 1. It is checked. If we tap it again, it's unchecked, it's gone. But like I said, I want to see the Smith chart because it's pretty. So I pick that. It's highlighted and checked. I choose format. Smith chart is checked. Excellent. I could actually do an SWR chart twice, but why I would do that, I don't know. But it allows you to do that. Okay, so next up, I want to test, this is a 2-meter handheld antenna, so I want to set the stimulus. And there's a couple of different ways you can do this. I'm going to set the stimulus start at 140 megahertz. I'm going to set the stop at 150 megahertz. And let's zoom in a bit here. All right, so we are now zoomed in. Get that light slightly out of the way, slightly better. Okay, I'm going to take my antenna with its SMA connector, and I'm going to take the end of the Nano VNA, and I'm going to marry those guys up. And you're going to see that the SWR is going to start to change, and this SWR does not look good. And there's probably a good guess as to why that SWR doesn't look good. It's a handheld
Ape's all
antenna.
proud.
It's missing a counterpoise. I can see Ape smiling in the corner already. When you're using a handheld radio,
I knew
you
it.
personally
I
know
knew
the
it.
counterpoise. So when I touch the outside part of this, you can see as I got my hands closer, we're at 19, and I bring my hand in, and we're starting to go down to 6.
I am becoming part of the antenna
outside
system.
Portion, we start to see a little bit of deflection on the chart over there on the side as I start to provide a human counterpoise. So I would know that if I am working with this antenna and I'm trying to do some testing, I'm going to need a counterpoise for it. So I would want to get the test set up to be optimal. But that shows you that the SWR is somewhere around 4 or so in this very crude form of measurement. So that's another indication as to why counterpoise are essential to running an antenna that doesn't have the other side. So I'm going to choose a different way of doing this. We did the start and stop. Now I'm just going to do the center. I'm going to do 146.52, the National Simplex calling frequency, megahertz. And at 146.52, the SWR is around 10 to 1, 7 to 1, 6 to 1 as I'm getting more and more part of the field. And the reactance on the Smith chart is 50 ohms. Great. My span is 10 megahertz. So I'm looking at 5 megahertz below 146.52 and 5 megahertz above 146.52. Let's change that span to be just 1 megahertz. And so now I'm looking at 145.52 to 147.52 with the center at 146.52. And we're at 3.5-ish to 1. And if I wanted to be so bold as to get another antenna out and set up a counterpoise and all that fun stuff, I could get that dialed in properly. This is just an example of how to measure SWR with a Nano VNA, and I hope that helped you out.
All right.
Very good.
I don't think we have
We've got a
anything,
counterpoise thing coming up after that.
Do we? The counter pi?
Yeah. It's the SWR, not SWR, it's the power meter one. That's where I bring up the counterpoise thing and show that antenna again. That's why it wasn't in there. That video was show you how to test SWR on a Nano, and then the next one is show you how to test power output on an HT.
Okay,
and that's where I do the thing.
We're going to do that right after Jim does an HT SWR test with a different type of tool. It's legitimate hand tool, so here it goes.
And we're going to do the same test on the same band range here, except our function has changed. And we'll just do this on VHF for now. And you want to look, in this case, at the top orange band. And let me scoot this up a little closer to the camera. KN4YCD test 1, 2, 3, 4. So about 1.5, 1.7 SWR. And if we switch over to VHF,
frequency mode.
K and 4 YCD test 1, 2, 3, 4. K and 4 YCD test 1, 2, 3, 4. So there we got about 1.4 to 1.5 SWR. And that is a common way to do this. Now, one thing I would point out that if you're only going to do a power test, you don't need an antenna on there. I would have put on a dummy load such as this MFJ model. I can't remember the exact part number. Ape has one of these. I has one of these. There it is. The MFJ 261 dry dummy load. This is rated from DC to 500 megahertz, 50 ohm impedance, and this is rated for 100 watts peak power and presents an SWR of less than 1.15. So if all you're doing is power testing on HTs, you need a dummy load. We're going to do SWR and power tests, so I didn't put one in, but there you go.
I like that little RS-40 meter. I got one of them.
Everybody should have one of those, man. It's handy because
Right
it's
here.
small. It does the thing. The only downside to that meter is it doesn't do HF. It's only VHF and UHF.
I think they sell them that do HF though. But they're significantly more. But like, there's no batteries, right? So this doesn't
Right.
require a plug-in or batteries. And then you can leave this in line with your circuit or your antenna. So what's really cool is like these are actually really good for in the car, right? So like if you have like an automobile
See you,
setup
Matt.
for later, Matt. If you have a setup in your vehicle for mobile and you just want to make sure you keep an eye on your SWR, this is something that you can run in line. Doesn't require any power. It's super easy to do that with.
Right.
So
And those
and they're
are
not
about
expensive.
yeah, they're like what, about $40, I think, for that thing.
Who knows with the chip shortage and all that
Right.
stuff, but yeah, I think I paid about $40 when I went and got mine.
And there are 26 different brands of that same exact meter. on
Yeah,
Amazon.
I think MFJ actually has one that's branded.
Yes.
Mine's in the say. I
Hitting
think
stretch,
yours was.
Greg.
What happened with Greg?
What?
Oh, he's talking about the 7th inning stretch. I was stretching.
Oh,
I messed up. I don't know what happened, but I messed up my my deltoid somehow, and it's been bugging me. So I got to stretch every so often.
let's switch over.
old.
Let's switch off of 80 meters now, and
So we got. It looks like it's the RS-70.
okay.
And then look who just showed up. Well, look who it is over here.
Derek, good morning.
Yeah, we had a great show with Derek on Sunday. It was on James' channel.
Yeah.
If you want to go
Thursday.
check
That
it
was
out.
Thursday. Hey,
What did I say? Sunday?
You did.
I'm telling you, man. I'm still waking up over here. And then Don is saying it's already 90 degrees. Whew.
yeah, I think it is here too.
I'll tell you what. All right, well, we're rounding the corner. We have one more video left to do. So let me remove this one from the stream or from the studio. And then let me go ahead and get the last one. I was worried that we weren't going to get through all 10, but looks like
Well, you had more on the agenda.
Well, you guys yelled at you, ham shamed me about that.
I had to narrow you down. I had to reel you in, big boy.
Yeah. So here we go.
Okay, this time we're going to test output
Here
power
it is.
from a
Counterpoise.
handy talkie, and not just any handy talkie, but UV5 Army.
And
This
it's
is
yellow.
a UV5RB model,
Hello, bang.
and these things are supposed to put out 5 watts or so.
B
Does it
stands for
say
better.
Anywhere?
It is better.
That is very professional since it's yellow. That is like a public
Yep,
safety
power 5 watts,
looking.
voltage 7.4. So let's see if we can get a full 5 watts out of this device. What do you
An
think?
MCOM's Baofeng.
This
That's
is
what
a
that is.
Shorecom SW102. Remember before when we were on the Nano VNA and I was talking about ground planes? This is an example of a ground plane.
Holy
for a 2
mackerel.
meter antenna, because we wouldn't have one and the readings would be a little awkward. So what I want to do first,
they made
is
a
I wanna
bigger
get
one,
the
I would've
ground
gotten
plane
it.
itself installed.
That's actually a thing? Oh my lord.
Or cookie
And then
tin.
we'll
Use
take
a
that same
use a
antenna
pizza pan.
Right?
that we used before.
Hey,
We're
pop
gonna
in a
need
cold
an
one.
adapter, because this
It's
is
Miller time.
SO239. So I need an adapter to go from SMA.
Oh, I need to go get one. I'm
to
dying.
UHF connectors. So we've got that screwed in. We've got that
Came with the
screwed
radio
in.
plasma. I don't know.
And then where'd my other piece go? All right. So for the other side, I'm going to need to do kind of the same thing where I need to go from
Amazon.
SO239 to SMA connector. So now we've got all of that rigging setup, and this
I feel like my measurements were not very professional now.
Full test.
Wow.
You would want to calibrate all of this stuff out of the equation. But for what we're doing today in this demonstration, this is plenty good enough. All right. So I've got my radio
is very professional
plugged into the input side of the test meter. See if I can get that unlooped some.
Yeah, you don't want to pinch the RF.
And then I've got my test meter.
I don't want to make it struggle.
I've got my antenna plugged in, and I've got my,
actually it's inductance.
I've got my ground plane plugged in. Let's turn it on. All right, we are powered on.
Probably the internet plasma.
All right, and we're in frequency mode. Yeah. My Baofeng lady tells me, and I am on 146.52, and I have my power meter here. And we are putting out 5.59 watts with 1.8 SWR, which is 2 and change SWR. The SWR went up as the power continued to go out. So it does indeed put out 5 watts. Let's zoom in so you guys can see that a little bit better.
It's a fast zoom. 5.9.
Right, so 5.89 watts, 5.35 watts, 5 point something watts in the upper corner.
That's a real radio right there.
And then
look at that
SWR
finger in there. That apparently
down
affects
corner.
that SWR a whole lot.
So you need to get yourself, well, you don't need to. You might want to, if you decide you want to test the output of your radio, you might want to get yourself a power meter. And make sure when you get your power meter that it is the same frequency that you want to test, and it has the scale to get you, like, if this was a 100-watt power meter and I put 5 watts into it, it would be really hard to read. So you want to get something that has the right kind of scale and cycles and power to accept the kind of power that you're going to put into it. So there you go. That's how you test the power output.
Does that auto scale?
SW2.
Yeah, it has a frequency counter in it. It'll actually tell you what the frequency is you're transmitting into it, and then it will tell you the SWR, and it will tell you the power output. Unless you were talking about the camera.
No, I was talking about the dingus. So does that well, my question was, so is that HF, VHF, UHF, or is it just 2 meter 440?
It's 2 meter 440.
Okay.
I've done a bunch of videos on that. Ape and I did a live stream on that a while back because it was reading kind of weird, and that's when I found out that incredibly scientific, extremely well built, high dollar bacon grease dummy load had a frequency roll off, and it wasn't able to keep up with the frequency I was putting into it. I think it's like, I don't know, 50K, and I was putting 144 meg into it.
Okay. I want to see you walk around with your reflective vest on and a ground plane on your Baofeng. That would be.
I'll hold up my ground plane antenna.
Right.
So let's talk a little bit about the ground plane that he attached on there. To me, that's cool, right? But it's only applicable to HT antennas or antennas that you have directly connected to the measuring device. Because if you have 20 feet of coax coming after that ground plane and your antenna, or your antenna's out in the backyard and you hook that ground plane up and you use it, it's not going to work as a ground plane for an antenna at distance from the meter.
Right.
But
so that ground plane is, as Greg was saying, the other half of your vertical oriented dipole. And it's the same thing as the radial wires you lay down for the DX Commander. And it's the same thing as the 4 wires that you bring down off of your quarter wave ground plane antenna. It's just flat.
Right. Ape, you did a video a long time ago.
I did.
You made a 2 meter ground plane antenna for your Fang or something like that.
Oh, I didn't think that was one you were talking about, but yes, I did do that. That was just a rat tails, what some people call them, just a radio on my 2 meter. I thought you were talking about the one. I did a video talking about ground planes for verticals and how the number of radials made a difference and modeled it in MMA&A. And one of the things that I put in there is that a lot of people are like, well, I like using vertical antennas regardless of the noise that they can pick up because they have a lower takeoff angle, which is better for DX. And all of that is true. But in that video, what I showed is that a dipole at the proper height actually has a better lower takeoff angle than the vertical. Right. But what Don pointed out at that point in time was good luck getting a 40-meter dipole up at the appropriate height, which is the part that I left out on purpose.
So you were spinning it.
No, I was just showing the facts as I saw them. Yeah, they can be a huge deal. What I wanted to do, and I could not do in MMA&A, and it's probably a limitation on my part, is what got me thinking about doing that video is that somebody was saying, well, if I have my DX Commander, whatever it is, mounted at the end on a fence, if I have it mounted on a fence, I can only put ground plane out on one side. Does that impact it? And the answer is absolutely. It absolutely will add directionality to your antenna, but you should still do it anyway, right? Like if that's what you got, that's what you got. You work with what God gave you, right? Mm-hmm. And you shouldn't let that stop you.
So that's why your DXCC or Worked All States awards are actually kind of important. It's not chasing paper that's the biggest part of that deal. It's like,
oh yes, it is.
Signal,
what did you just say? This will not stand.
Barry, let me redeem myself before you cut me off and ham shame me right out of existence. If my antenna in Northwest Wisconsin, you already have, can't make it to Alaska, it's on me to fix that system somehow, to work with the environment that I have, the equipment that I have, the abilities that I have, level up those abilities to make that contact happen. And sometimes that ability might be like sending an email to a known ham in Alaska and saying, hey, are you free at 2 p.m. tomorrow Central Time? Mm-hmm. And let's get on the radio, and then we'll figure that stuff out. But not every antenna is going to work for everything all the time. That's not possible.
Yeah. Right. Well, we've said it.
Did I redeem myself?
You did. We've said it mostly. We've said it on this show before. Everybody said it 1,000 times on y'all's videos. Every antenna system is a bit of a compromise, one way or the other. It'll work as well as it's going to work. So, really.
I've been having fun with the soundboard.
I haven't even started with mine. I've reeled mine in.
I use it on work conference calls sometimes too. People definitely do not like the crickets if somebody's talking at work. You play that. So Ham Bandit says he built a 3-foot copper ring, and then he set it to vertical and measure distance from DX Commander, and it makes it a directional from ground. I had to hear more about that. Sounds interesting.
Vertical at a measured distance.
Okay, Don says everybody spins that part. Height is a problem with the dipole. Totally is. I finally got MenFed half wave at 34 feet. Makes a huge difference. Still not close to the DXE, but way better than 15 to 20 feet. Yeah, that's the problem. The challenge is that when you use not verticals, but like horizontals or slopers or inverted L's or any of that kind of stuff, multi-banded antennas, there is no right height for that antenna because it's different depending upon band and frequency. So like that's when we talk about compromises, that is that's the problem. That's the challenge there. Ham Bandit says he's got a video coming out showing it. I did not know the Ham Bandit had a YouTube channel.
I don't think I knew that either.
Let me see if I can find it. I'll link it.
That's awesome. And good morning, KO4 NLB. We're actually getting ready to shut her down. I think we didn't have anything else. Does anybody in the comments have any questions or anything that they wanted to cover or talk about? While Tio is looking for Ham Bandit's YouTube channel,
I found it.
Go ahead and give him a sub while you're at it.
Already subbed.
I don't know if I have. I'm going to have to check.
Yeah, I have to check too, but I'm not going to do it right now because my configuration is so sensitive. I don't want to mess anything up.
Right. Yeah.
So I guess I'll just say if everybody enjoyed the show, let us know. Maybe a one in the chat and
smash the like.
Yeah, just let us know, and then we'll do another one or continue on with these. We don't want to do it if folks don't like them.
I think what we're talking about, and y'all let us know for reals, is maybe doing something like this once a month, maybe on one of the shows.
Once a quarter, whatever makes sense. Yeah.
Yeah.
But as you saw, it was a lot of work to put this together.
Yeah,
tremendous amount of work.
When we first laid out the plan, everybody's like, "Are you kidding me?"
Yeah, Ape sent us this long list. I'm like, bro, I got a job. I mean, I don't know what you do all day, but I got a job. I ain't,
Max and relax, Playboy.
ain't nobody got time for this. Just saying. Ain't nobody got time for that.
Yeah, so we said we'll break it up, and then Tia was like, "Well, we could do this as a multi-part thing." So
4-part miniseries with a nice story arc to really reel them in. Yeah,
we got to get Richard Chamberlain for this.
So really we got KC0 TAF. Mike is asking if we put more Car-10 in the store. So we are going to be adding the Apollo, which is the new version of the Artemis, in a couple weeks.
Speaking of work,
we're waiting for Chuck to get back from his vacation, and we have to do an inventory. Slackers. And find out what we have parts spread across the United States. So we just need to figure out what kind of parts we have, get them all in a central location, and get the kit assembly. So,
and if any,
it's coming.
Yeah, and if any of you are thinking about buying an Artemis, you're too late. And if any of you are thinking about buying a Mercury,
we made it better. It's not gone. It's just improved.
The Artemis is gone. The Artemis is discontinued. The Apollo will be better, but you got to wait for it. However, the Mercury, that's right, 2.0. 1. We're going to skip 2.0 completely because that's always buggy. We'll go to like 2.03 or something like that. The Mercury is still available in the store, and there are 4 left the last time I looked.
Right, Plasma?
Well, Chuck sent out the last ones, but we're targeting TO.
Yeah.
And Don's waiting for the Car-10 hex beam. We'll have to talk to Chuck about that.
Yep.
He does have a smaller hex beam that is pretty slick. So we'll see what we can do. All right. Did any of you boys have anything else you wanted to throw in there?
No. Thank you all for watching. Had a great time.
All right. Well, thanks everybody. Totally appreciate it. And we'll see you next time. Hit the end broadcast button, but